Guys, welcome to Balancing Chemical Equations. We're starting a new unit, so we're going to be doing a lot more chemistry. What I have for you is an example equation that you guys have all seen before in honors biology, and of course this is our cellular respiration equation that you've had. What I want you to notice about it though, just to be sure that we all understand the basics of chemical equations, of course it's representing a reaction, a chemical reaction. It also, what you maybe didn't see in biology, it has these little letters here, little symbols, and those represent what phase that we're talking about, what phase of matter. So like the S means that this is solid glucose, and of course oxygen right here is a gas. And we also have another gas, our CO2, and then we can have water, which is a liquid. So we're going to be writing those in our chemical equations later on in this unit, so it's good to go ahead and get used to seeing that. You also see one that's not shown, and it's an AQ, which will be aqueous, and that means things that will dissolve in water, but you don't have it in that equation. The other thing that you probably remember is you had to have these in front, and we don't have it here, but that's actually, it's like saying there's a 1. We don't put 1s, but we can act like it's there. These are the coefficients. And those coefficients in front of these molecules, these compounds, those are there to balance out what's on the left side and the right side. And that's because everything on the left side, the reactants, which are all on this left side, and the products, you have to have an equal amount of the reactants and the products because of something called the law of conservation of mass. With the law of conservation of mass, we know that matter can't be created or destroyed. It can only be transferred one place to another. So if I have, say, 6 carbon atoms on this side, I can only show 6 on that side. I can't have 8 and then 2, poof, carbons just showed up. Like it had to come from somewhere. So our reactant side has to match our product side in terms of the amount to follow the law of conservation of mass. The last thing on this equation, probably remember this. This represents that something was produces, or you'll also see yields. So in other words, glucose plus oxygen produces or yields in this reaction carbon dioxide and water. Okay, so that's just an overview. We'll be hitting those a lot more. What we really want to focus on today, though, is how do I balance? How do I make sure that I'm actually following this law of conservation of mass, and that whatever I have on the reactant side is going to match the amount that I have on the product side? And so one of the things that I like to do, I'll keep this color, is I'll draw a line between to represent reactants versus my products. And then I like to do a quick survey and inventory of what I have. So this 2 subscript means I have 2 hydrogen, so 2 hydrogen atoms on that side. And then I look over here and I have 2 hydrogens on that side. And then I look for my oxygen, and that 2 means that there's 2 oxygens on this side. And a lot of times I'll go ahead and write oxy, because if not, like later on, it almost looks like I'm writing a 20, which is kind of confusing. And on this side I have 1 oxygen. And so right now this equation is not satisfying the rule that whatever I have on this reactant side was what in a different combination is on the product side. What's off is clearly the oxygen. I have the 2 hydrogens, so that's good. But my oxygen, I have 2 on this side and 1 on that side. So how am I going to fix that? Well, if I put a 2 right here, that coefficient means that everything in this formula is multiplied by 2. So that means that 2 times 2, I had 2 hydrogen, so now I have 4. So, I've messed up this balance. We'll worry about that later. Now I have 2 times, no subscript there means 1, so I have 2 oxygen. So I'm like, yay, my oxygen's good. But my hydrogens are not good. So I got to go back and fix that. And that's what you guys are going to find with balancing. It's just going to be a back and forth to make sure that whatever I make change over here, that it's going to change other things occasionally, and I got to come back and check. So for my hydrogen, if I have 2 on this side and I need 4, if I put a 2 right there, 2 times 2 makes 4. So my hydrogen, check, that's balanced, and my oxygens, they're balanced. So this is all you have to do to balance, is just to match those things up. Some people like to put a 1 here if there's a blank. Just know in a normal equation that you wouldn't show a 1, but if you want to put a 1 there for blanks, that's up to you when you're solving them. Okay, so let me show you another one on this side. A little bit harder. Still not bad though. I'm going to draw my line. And I'm going to do my inventory. So I have one barium on this side. And I have one on this side, right here. And then I have one sulfur. And I have one sulfur. I have 4 oxygen. And I have, oops, that's already been balanced. Okay, that's not there. Pretend it's not there. It's gone. It's not there. Okay. Poof. I just broke the law of conservation. Okay, so there's nothing there. There's just one oxygen there. I got excited, started balancing. Okay, and then I have one carbon here, and I have one carbon there. Okay, so you're going to be shocked to find out how we balance this, but if I look at my barium, they're great. I look at my sulfur, they're great. But the oxygen is not balanced. That's what's inaccurate about this, not representing with my coefficients. So I have to be sure and show that. So here's the shock. If I put a 4 here, I now have 4 oxygen. But if you guys notice, I also changed my carbon, so I have to go back and put 4 carbon. So now my carbon's not right. But it's pretty simple on this side because carbon's sitting there all by himself. So if I put a 4 there, now I have 4 carbon. So I have 1 barium, 1 sulfur, 4 oxygen, 4 carbon. So this is a balanced chemical equation. And I can put 1s in here to show that I did balance those, but they don't have any coefficients needed. One last example for you guys. This one, sometimes it looks a little daunting, you know, with all of the, you know, it's like we have polyatomics in here, and so there's a lot of like bigger compounds, so sometimes this can be daunting to people. So what I like to do, if at all possible, I'll go ahead and write like have 1 calcium over here, and I have 1 calcium over here. But what I see over here, this is a polyatomic, the hydroxide polyatomic, and so what I like to do, sometimes the polyatomic in the reactant side looks the same in the product side. So sometimes I try to keep them together if at all possible. Sometimes it's not possible, so we'll keep that in mind. I'm going to go ahead and skip the polyatomic and go to sodium. I have 2 sodium, and I have 1 sodium. And then again, here's another polyatomic. So what I like to do is kind of save those for last and just check and see what happens to them. So like on this side, I actually have 2 OHs, which we can see from right there, because over here it's clumped together and I have 1 OH. And sometimes you're going to have to break those up in individual oxygen, like 2 oxygen, 2 hydrogen. But in this case, because an OH is here and an OH is there, I can actually just kind of collectively look at it as a hydroxide polyatomic. The same thing with CO3, which is carbonate. I have 1 carbonate. I just put these in parentheses so it doesn't confuse you. And I have 1 carbonate. So what I like to do is just try to focus on the non-polyatomics first, because a lot of times that then by default balances my polyatomics, which is good. So for example, my calciums are okay, but sodium's not, so I have 2 here. If I put a 2 in front of the sodium, then now I have 2 sodium, because 2 times the 1, that makes 2. But I also have 2 of these hydroxide, 2 O's, 2 H's, which is like 2 hydroxides. So if you can see from this equation, I now actually balance these, not even meaning to, because I balanced the sodium. So a lot of times I'll do the single elements first, and then I'll go for my polyatomics. There's a whole lot of tricks to balancing, and you're going to be going over a lot of those in class, but as long as you always check to be sure that your reactant side matches your product side, you should find that it's a pretty easy thing to do. Hope you guys found this helpful.